Welcome to The Explainer. I am so thrilled you're here today because we're diving straight into an exclusive masterclass. We're tackling the energy, work, and power section for Cambridge AS and A-level math. Specifically, we are cracking the code on syllabus 9709 and the infamous work done formula. Now, if you've been grinding through past papers, just burning the midnight oil and wondering why your final score doesn't really reflect all that effort, well, you're in exactly the right place. We're going to look at this strictly through the lens of what Cambridge examiners literally want to see on your paper.
Just listen to this quote. Most students lose easy marks on work done, but after this explainer, you won't be one of them. That is our promise to you today. The stakes in these exams are high, right? And falling into common, totally avoidable traps can absolutely cost you the grade you deserve. The gap between an average paper and a top-tier paper isn't always about knowing more math. Honestly, it's about knowing how to apply it, how to write it down, and how to dodge those classic pitfalls that show up in the principal examiner reports literally year after year.
Okay, here's our game plan for securing those lost marks together. First up, we'll look at the core trap. Then, analytical depth versus superficial breadth. Third, the method mark strategy. Fourth, deconstruct, solve, and evaluate. And finally, the top 3 examiner warnings. Let's not waste any time. Section 1. The core trap.
So the syllabus makes it super clear. Top-performing students show a deeply connected conceptual understanding, but, students consistently struggle with taking these math concepts and putting them into unfamiliar contexts. It's one thing to solve a problem you've seen 100 times in your textbook, but it's an entirely different beast when Cambridge throws a completely wild, novel scenario at you on exam day. And that brings us to the fundamental equation. Work done equals force times distance times the cosine of theta. W equals Fd cos theta. You probably have this burned into your brain by now, but here's the trap. Merely knowing the components, work, force, distance, and the angle, is only half the battle. If you just blindly plug numbers into this equation without truly understanding the physical context, like the actual direction of the force or its line of action, well, you're walking right into the examiner's trap.
Section 2. Analytical depth versus superficial breadth.
So what are the examiners actually looking for when they're grading your response to a work done question? Spoiler alert, they aren't just checking your final answer. There is a massive distinction here between superficial breadth and analytical depth. Superficial breadth is basically just memorizing the formula. It's knowing W equals Fd cos theta, but completely freezing up the second a question introduces an inclined plane and a weird frictional force you haven't seen before. The academic benchmarks for Cambridge 9709 demand logical, structured reasoning. The whole assessment framework heavily prioritizes analytical depth. They literally want to see that you can take this basic formula and reason your way through a completely unfamiliar context step by step.
Section 3. The method mark strategy. Okay, so how do we actually prove that analytical depth on paper? Enter the method mark strategy. This is basically the insider secret of top-scoring candidates. In Cambridge exams, practical application develops professional skills, and marks are heavily awarded just for your process. To lock in those marks, you need a tight 5-step procedural framework. Number 1, deconstruct the examination question. 2, extract the relevant data. 3, select your analytical framework, which here means your energy, work, and power principles. 4, execute with super clear mathematical notation. And 5, present your final answer using the exact correct terminology. If you visibly walk through these 5 steps on your paper, the examiner literally has no choice but to award you method marks, even if, some minor arithmetic error throws off your final calculation at the very end.
Let's zoom in on step 2 for a second, extracting data. Your data interpretation skills are absolutely critical here before you even think about plugging a single number into W equals Fd cos theta. You're going to see data sources like complex texts or tables. Your job is to extract that data, interpret the relationships, like really identifying which force is actually doing the work against the angle of motion, and then draw evidence-based conclusions. You basically have to map out the physical reality of the whole problem before the math even begins.
To help with this, I've got a fantastic memory hack straight from our source material. It's called the visual story method. Don't just stare at the words on the exam paper. Try to encode the concepts by physically picturing the problem's context in your head. Imagine the block literally sliding down the ramp. Visualize the exact angle of the force pulling it. If you can see the story unfold in your mind, you'll almost never mistake which angle to use for theta, and you'll perfectly map out the forces doing the actual work.
Section 4. Deconstruct, solve, and evaluate.
All right, once you've pictured that scenario, we move into the critical problem-solving loop.
This is absolutely essential for advanced critical analysis in the 9709 syllabus. Notice it's not a straight line, it's a continuous loop that keeps you totally grounded in reality. It breaks down into equal slices. First, identify the given info. Then, break it into logical steps, solve systematically, and then, okay, this is the really big one, check for reasonableness. Look, if you calculate the work done by a person pushing a tiny box across a room and your answer is somewhere in the millions of joules, well, that check reasonableness step should immediately set off alarm bells in your head. Finally, you make justified recommendations or conclusions based on that systematic analysis.
It's super interesting how this problem-solving loop perfectly maps to Cambridge's 3 distinct cognitive domains. Identifying information? That proves your knowledge and understanding. Breaking it down and solving systematically? That proves your application. Checking reasonableness and making conclusions? That proves your analysis. When you use this deconstruct, solve, evaluate loop, you are literally handing the examiners the exact cognitive proof they need to give you a top score. It's a total game changer.
Section 5. Top 3 Examiner Warnings. We've talked a lot about what to do, but now we really need to talk about what absolutely not to do. These are the top 3 mistakes pulled straight from the Principal Examiner reports for the Energy, Work, and Power module. Pay super close attention here. Mistake number 1, using the wrong approach for the context. This goes right back to that superficial breadth we talked about, basically trying to force a formula where it physically doesn't apply. Mistake number 2, forgetting format and presentation. Look, if the examiner can't easily trace your logical reasoning, you kiss those method marks goodbye. And mistake number 3, answers lacking specific context. If your final answer is just this naked number floating there without units or a clear connection back to the specific physical scenario in the prompt, you're going to lose marks, for sure.
And guys, here is a massive, flashing examiner alert straight from those reports. Candidates consistently confuse key terminology. Work, power, force, energy. These are definitely not interchangeable words. They each have highly precise mathematical and physical definitions. The examiners are basically begging students at this point, always define your terms clearly and apply the correct terminology all the way through your extended responses, because precision in your language totally proves precision in your thinking.
Let's do a quick recap to really lock in this new exam strategy. To completely conquer W=FD cos theta, you've got to do 4 things. First, apply the method mark strategy by visibly showing your step-by-step reasoning. Second, use the deconstruct, solve, evaluate loop to catch those silly errors and prove your analytical depth. Third, precisely define your terminology. And above all else, avoid superficial breadth by truly visualizing and understanding the real-world physical context of the problem.
As you head back to grind out some more past paper practice, I really want to leave you with this one provocative question to think about. When you sit down to solve a problem, are you just blindly calculating numbers, or are you actually proving your analytical depth? Try to shift your mindset from just finding the answer to building a bulletproof, logical argument right there on the page. Because honestly, that is exactly how you crack Cambridge Math 9709. Thanks so much for hanging out with me on The Explainer today. Keep crushing those past papers, and I'll catch you next time.